Welcome to this topic, functions with a focus on domain and range. We are going to look at the 3 most recent available past paper questions on this topic. First is from 2021, question 2, state the range of f. These questions are normally just 1 or 2 marks, but they can involve quite a lot of work, so the marks are not proportionate to the amount of working out needed. By and large, you usually will need to do a sketch for these. So in this case, it's quite straightforward because f of x is a quadratic, it's a negative quadratic, and the domain is any real number, so x can be anything. So the graph looks like that, there's nothing we need to delete from it. Looking at that, you can see that the range, that's the up and down values or the y values, can be less than or equal to 7. They can equal 7 in this case because x can be anything. So at the highest point where we have x equals to 0, that's when y can equal to 7. And then for part B, we've got a composite function, g f of 1.8. Option here is to break it down into its parts, so you can find the inside bit first. That would be f of 1.8, just using your calculator. Getting 0.52 as a decimal, or you can write it as a fraction. And then the second bit would be plugging that into g. So g of 0.52. Again, just type that into your calculator. Answer of 0.975. Last part for this, part C, find g inverse of x. So finding inverse functions, it's the same every time. It's just a few steps involved. First one, I would always write y equals instead of your g of x or f of x. Second step is to rearrange to get x the subject of your equation. Usually this would involve some kind of expanding followed by a factorising. In this case, we're going to factorise out the x. And then there's a final step, which is to rewrite the x as what we were looking for, in this case, g inverse of x, and to swap the y for an x. This isn't particularly mathematical, it's literally just a trick to help you find the inverse function. We essentially just did the original function backwards. Next question, 2022, find f inverse of 3 over 2. So in this question, we've been given f of x, and I think most students would probably start working out the inverse function. But I can see that that's going to require quite a few steps. It's only 2 marks. So we can use our knowledge of functions. In this case, we're looking for a value, f inverse of 3 over 2. Let's call it x. You can actually manipulate this by taking f of both sides, using the knowledge that an f and an f inverse will undo one another, leaving us with 3 over 2 on the left-hand side. And then on the right-hand side, it says f of x. So we can take our f of x, set it equal to 3 over 2, and simply solve it that way. You can solve this on either class whiz using the solve or solver function on your calculator. I think this is much quicker than working out the inverse function, and in some questions you will have to have this knowledge of how to rearrange questions using the fact that f and f inverse undo one another. So it's important to know. Answer is minus 0.1. Part B, show that question. So we've been asked to rewrite f as 2 terms. This is a really common type of question. It's necessary for being able to sketch and for being able to find range and domain of this function, because the function in its current state isn't really easy to work with. So the trick to this is to write your denominator on the numerator. So write 2x plus 3 up in the numerator and then work backwards to see what you need to do to it so that you still have f of x. So if I put a 4 outside the bracket, we'll get out 8x, so that's good. But we've also got 4 times 3, which is going to give us 12, and we want 8x plus 5. So then we'll minus 7. The reason we did this is because now you can see by copying the denominator up in the numerator, I can now cancel them, leaving us with an integer, or in this case 4, and then we've still got the fraction that we needed. In this case, it's minus 7 over 2x plus 3. Part C, we need to find the range of G inverse. The range of the inverse function is the same as the domain of the original, in this case we've been given it. So we just copy that down, making sure to write y instead of x. And then finally, find the range of FG inverse, 3 marks. Quite a tricky question. Range of a composite function. The main thing to know here is that we're going to focus on the inside first, just like we did before, and we know the range of that, we just wrote it down. So we know the range, the output values, G inverse of x, but now those are going to become your input values when you put it into F. In other words, they become your domain along with the original set domain, which was up at the top, x is bigger than minus 3 over 2. So we've got 2 parts to this domain now. I highly advise doing a sketch. So F, we've just rewritten F so that it's more easy to sketch. This is a reciprocal graph or a negative reciprocal graph with a y transformation. Technically there's a times 7, but the one that will affect the asymptote is the add 4, so that becomes y equals 4. And we've got 2 x transformations, making the x asymptote of 0, it becoming minus 3 over 2. And then we've drawn it in top left, bottom right quadrants because it's negative. And then taking into account the domain that I said, we have got x is bigger than or equal to 0, less than or equal to 4, shading that part in or deleting the rest of it, you'll be able to work out the y value from the f of x function. So sub in a 0 and you get 5 over 3. Sub in a 4 and you get 37 over 11. And it's inclusive because the x values were also inclusive. Next, we've got this question which is talking about range of f, where f is a root function. So a root function looks like this, but we've got 2 transformations happening on it. We've got the plus 3, so that's the y values, and we've got x minus 2, so that will add 2 to the x values. This is using your knowledge of transformations. So when we apply those, it will look something like this. X is any real number bigger than 2, so nothing needs to be rubbed out. That's what I'm seeing on my sketch. And I can read off how low down and how high up it can go. So it can go down to 3, it can't equal 3 because x can't equal 2, and it can go up to infinity. So we can just write y bigger than 3 for that one. Next, we have to find the inverse. Same steps as the previous question, writing y equals and then rearranging to make x your subject, and then making sure you write f inverse of x equals and swap the y's to an x. For this one, they actually expected you to write down the domain because there was a restriction on it. So please watch out for that because that is one of the 3 marks. The domain will be copied from part A. So the range will now become the domain. It's worthwhile always copying that down if you've already worked it out, because even if your previous answer was wrong, you will still be awarded the follow-through marks. So you will still get the mark for writing x's and then just copying your answer to part A. C, we have another composite function, g f of 6. Again, you're welcome to start with the inside, breaking it down by doing f of 6 first, and then we can do g of 5. Answer can be left as a fraction. And then finally, part D, find the exact value of the constant a for which. So we need to do f of a squared plus 2. So wherever you saw an x in your f, you will replace it with a squared plus 2. And then setting it equal to g of a. So wherever you saw an x in g of x, you now just replace it with an a. With functions, if there's a square root sign, please assume it's the positive. Rearranging this to solve for a. And if you're not sure, you can always take your answers if you do end up with a positive or a negative one, and you could also always sub them back in and see if they both work. What we don't want to end up doing is subbing them in and seeing that we've got the square root of a negative number. Great, so that brings us to the end of our 3 exam questions on functions, range and domain. If there's anything else you would like to see me cover, please let me know by commenting. Otherwise, good luck in your exams.